Yes. Now we'll see the next model. N jobs, N jobs, M machines. N jobs means if the number of jobs given in the problem is more than two, either three jobs or four jobs, five jobs, any number of jobs above two, it is called N jobs. M machines means we've already seen N jobs two machines. Specifically, there is a model for it. N jobs two machines model. N jobs three machines model. That earlier model you have seen. Now, if the number of machines is more than three, we can call it as M machines. Any number of machines may be there above three. N jobs four machines, N jobs five machines. So any number beyond three, we call it as N jobs M machines model. So that's the meaning of N jobs M machines here. So here also Johnson's algorithm can be applied to solve this particular model. See, the problem will be given like this: A, B, C, D, E. Five machines are given. It's not three machines. If it is two machines, N jobs. If three machines, N jobs. Earlier models have seen. Now, number of machines more than three, and number of jobs more than two. So this is now a model coming under N jobs, N machines. So for this also, Johnson's algorithm can be applicable, can be applied. Only thing is you need to test the conditions. What is the condition? The minimum processing time on the first machine. First machine for all the jobs time data will be given. What is the minimum processing time on the first machine of all the jobs? That time noted. Then maximum processing time of all the processing times on the remaining machines, leaving first machine, last machine. First machine A వదిలేయాలి, last machine E వదిలేయాలి. The middle machines, what is the maximum processing time? The middle machines maximum processing time. So if the minimum processing time on the first machine is greater than or equal to maximum processing time on the remaining machines, middle machines say, leaving first and last machines, then the condition is satisfied. If this condition is satisfied, it's okay. If this condition fails, then you check this condition. The minimum processing time on the last machine data, last machine for all the jobs, time data will be given, time durations will be given. What is the minimum of it? So every time first minimum processing time on the first machine is compared with maximum processing time in the middle machines. Minimum processing time on the last machine is compared with maximum processing time on the middle machines. So if the first condition fails, check this condition. Any one of these conditions, if satisfied, you can go for Johnson's algorithm. One condition is enough. You don't require to verify both the conditions. If the first condition is satisfied, you don't require to go to the second condition. If the condition fails, then only go for second condition, check it out. Both the conditions need not be satisfied, remember, to apply Johnson's algorithm to this problem. So that's what it is. Now, first of all, if five emissions data is given here, five emissions A, B, C, D, E, five emissions data is given, and you need to convert the given problem into the n jobs of two machines. N jobs two machines. You must convert this given data to n jobs two machines only to apply Johnson's algorithm. Because Johnson's algorithm is clearly written, is clearly designed only for n jobs two machines, but with slight modifications, slight assumptions, slight conditions. We are what you call converting the given problem into n jobs two machines problem and finding the better sequence. Once the better sequence is obtained, then you are using the real-time data, real-time machines data only for calculating the total completion time. So here also 256 machines must be assumed. Instead of 5 machines, we will assume only 2 machines, GI and HI. G and H. G and H. So processing times for these imaginary machines will be computed like this. How sum of the processing times of job I for all machines except last one. Leave the last machine data. Sum up all the processing times for the first machine from the first machine to last but one machine. You get processing times for G. Similar processing times for H. Leave the first machine A. Omit the first machine. Consider only the processing time data on the machines B, C, D, E. Sum up all the processing times for each and every job. You will be getting the processing time for H. See here, GI equal to AI plus BI plus CI plus DI. HI equal to BI plus CI plus DI plus EI. Okay, this one. So this is the given problem for 4 jobs are there, 5 machines are there, and the condition, verify the condition, whether the condition is satisfied or not. Minimum processing time on this is machine year list 5. What is the maximum processing time on the middle machines, leaving the first mission, last mission? First mission వదిలేయాలా, last mission వదిలేయాలా? What is maximum processing time on the middle machines? Middle machines B, C, D. వీటిలో maximum processing time ఉంది 6 ఉంది. 6 ఉంది. So whether 5 is greater than or equal to 6, 5 అనేది minimum processing time on the machine A. Minimum processing time on the first machine. Is it minimum processing time on first machine equal to 5? Maximum processing time on the machine, middle machines is 6. Is 5 greater than or equal to 6? No. So first condition failed. Then in case first condition fails, as first condition fails, now you check the second condition. What is the minimum processing time on this last machine? Minimum processing 6. What is the maximum processing time on the middle machines? 6 only. Earlier we found. So 6 greater than or equal to 6. Minimum processing time on machine E equal to 6. Maximum processing time on BCD equal to 6. So 6 greater than or equal to 6. 6 greater than or equal to 6. 6 equal to 6. So second condition is satisfied. Hence Johnson's algorithm can be applied. Now group the machines and assume two imaginary machines G and H like this. So what is G? G equal to A plus B plus C plus D. H equal to B plus C plus D plus E. So while combining the processing times for G, it is mission, leave the last mission data. Leave the last mission data, sum of the processing times for the first machines only, first A, B, C, D only. Then while calculating the times for processing times for the imaginary mission H, leave the first mission data, B, C, D, and the processing times on B, C, D, E only should be clubbed. So now we got this one. So GA equal to, see here, GA equal to G1. So for the machine G, sum of these processing times 8 plus 6 plus 2 plus 3. Leave this one. This 9 should not be there. 8 plus 6 plus 2 plus 3. Leave this column, last column. Sum of the processing times, first 4 machines. 8 plus 6, 14. 14 plus 2, 16. 16 plus 3, 19. 19 is there for G. See, 19. First mission, first job. Then second job GA. Second job, sum of these values 6 plus 6 plus 4 plus 5. 6 plus 6, 12, 12 plus 4, 16, 16 plus 5, 21, 21, 21, 21 of G in 1 minute. 6 plus 6, 12, 16, 16 plus 5, 21 only, it is not 22. This is 21, sorry, it's 21. Then for the third job, 5 plus 4 plus 5 plus 6. 5 plus 4, 9, 9 plus 5, 14, 14 plus 6, 20. 20. Third job, 20. Similar fourth job, 8 plus 3 plus 3 plus 2. 11, 11 plus 3, 14, 14 plus 2, 16. 16. So like that, processing times for GI have been computed. Similarly, processing times for H can be computed by leaving the first mission data. This you omit. First mission data will remaining missions full code. B, C, D. 6 plus 2 plus 3 plus 9 for first job. For first job or for imaginary mission H, what will be the processing time? 6 plus 2 plus 3 plus 9. 6 plus 2, 8. 8 plus 3, 9. 8 plus 3, 11. 11 plus 9, 20. See, fictitious mission H, first job 20. Like that, compute for the second job from this. Leave the first mission data. 6 plus 4, 10. 10 plus 5, 15. 15 plus 10, 25. 25. So like this, fictitious missions G and H are assumed. Processing times are computed like this. Using these equations, you can calculate for the job I. For the job I, processing time for G, processing time for the ith job on G can be computed like this. Leave the last mission data, sum of the processing times for each job you will be getting it. Leave the first mission data, processing time data will be put in for each. So like this. Now put some 4 compartments. Why? Because 4 jobs are there. These 4 jobs are to be sequenced now. N jobs to missions model is to Johnson's algorithm is to be applied now, as this problem is now in the form N jobs to missions. So we need to find the sequence only. First of all, to find the sequence only, we have to use this data, fictitious machine data. So there are 4 jobs, hence 4 compartments. 1, 2, 3, 4. Let us empty compartments are there. to start with. Empty compartments are there. Nothing is there in it. Nothing is there written here. Assume that four compartments, empty compartments are written. Now, Church's algorithm can be applied step by step. So identify the smallest processing time in the list 1 and the list 2. Combinedly, in all the processing times here, minimum processing time is 14. This is occurring on the last machine, not on the first machine. This 14 is occurring on H, not on the first machine, and this corresponds to the fourth job. Hence, job number 4 must be positioned at the end. Why at the end? This minimum processing time is on the second machine, not on the first machine. If minimum processing time is occurring on the first machine, that corresponding job number must be placed at the beginning. So you know that. So read the algorithm twice, thrice, interpret it properly. So 4 compartments, last compartment, job number 4 must be put. So E4 it వచ్చింది. Assume that nothing is there here. ఇక్కడ 4 ఇక్కడ పెట్టాను first. Assume that nothing is there here. ఇక్కడ ఏం లేవు. So 4 last compartment of 4 will. So once job number 4 positioned, you just neglect this data. Data is అవసరం లేదు. So in the remaining list 19, 22, 20, 20, 25, 23, what is minimum? Minimum is 19. This minimum processing time is 19. This is occurring on the machine G, first machine itself. So corresponding job number is 1. So job number 1 should be positioned in the beginning of the sequence. అంటే 4 compartments లో ఫస్ట్ వచ్చే జాబ్ నెంబర్ 1 అంటే వస్తుంది. సో 4 ఇక్కడ ముందు వచ్చింది, ఇప్పుడు 1 ఇక్కడికి వచ్చేస్తుంది. ఎందుకు? మినిమం ప్రాసెసింగ్ టైమ్ ఈస్ అకరింగ్ ఆన్ ది ఫస్ట్ మిషన్, కరస్పాండింగ్ జాబ్ నెంబర్ మస్ట్ బి ప్లేస్ ఇన్ ద బిగినింగ్ ఆఫ్ ద సీక్వెన్స్. సో ఇది కూడా అయిపోయింది కాబట్టి దీన్ని వదిలేయచ్చు. యూ కెన్ లీవ్ దిస్ డేటా. సో ఈ కాలం వదిలేసినాం, ఈ కాలం వదిలేసినాం, ఇంకా ఈ 2 కాలమ్సే ఉంది. ప్రాసెసింగ్ టైమ్స్ ఏమున్నాయి ఇప్పుడు? 22, 20, 25, 23. So among these processing times 22, 20, 25, 23. So 21 and 21, 21, 20, 25, 23. So what is minimum? Minimum is this one. So this is occurring on the first machine itself, G, and the corresponding job number is 3. Hence job number 3 must be placed at the end. At the end and 4 already which కూర్చోండి ఇక్కడ. So next to last అంటే job number 3. Sorry. So this minimum processing time 20 is there on the first machine, sir. Then first machine, the corresponding job number must be placed in the beginning of the sequence. Beginning already 1 ఉంది. So next to the first, ఇక్కడ నుంచి వేసుకోవాలి. So if the minimum processing time is occurring on the first machine, what to do? You have to fill the compartments from left to right. If the minimum processing time is on the second machine, you have to fill the compartments with the job numbers from right to left. So 3 is coming here. So 19 is up. 19 ముందు అయిపోయింది. And now it comes 21, 22, 25, 23. 20 is there on the first machine. Hence corresponding job number must be placed in the beginning of the sequence. Beginning లో already 1 ఉంది. Next compartment లో 3 వస్తుంది. So 1, 3 వచ్చేసింది, 4 వచ్చేసింది. ఇంకా only one job remaining, that is second job. That will be occupying here. This is how the optimal sequence is to be found out. Once the optimal sequence 1, 3, 2, 4, only one best sequence is found. If that is found, see 1, 3, 2, 4. The Ranichi original machines must be considered, not the fictitious machines. Machine A, machine B, machine C, machine D, machine E. So earlier I have seen 3 machines. How, at what time? Assume that at clock time 0, what starts for the first job, initial job, depending upon the operation time. So time of completion can be computed. 0 plus operation time for the first machine, for the first job. First job on this machine 8. 0 plus 8. 0 plus 8. 0 clock time 0 it is loaded. 0 plus 8 it comes out. So at clock time 8 it can take next job in the sequence. First of all, computations on machine A must be completed. Then you can go for machine B. Then first machine A computations must be done. 0 plus 8. So at clock time 8 it can take next job in the sequence, that is third job in the sequence. For third job on machine A, what is the time for completion? 5. 8, 5, 5, 5. Operation time is 5. So 8 plus 5, 13. 8 plus 5, 13. Look into the machine data, original machine data. So at clock time 13, operation on third job is completed. It is unloaded. Now the machine is ready to take next job in the sequence. At clock time 13. So clock time that is taking. For second job, what is the time on machine A? That is 6. Look into the original data. 13 plus 6, 19. This clock time 19 it comes out. Then at clock time 19 it can take next job in the sequence. So plus 8 plus 8. Operation time on the machine A for the fourth job 8. So 19 plus 8, 27. So like that, machine A computations must be first completed. Then I told you all the given jobs 1, 3, 2, 4. I mean 1, 2, 3, 4 in the sequence 1, 3, 2, 4. They must flow through machines A first, then B, then C, then D, then E. These machines are seated installed permanently. Machines will not be disturbed. So all these jobs will go through first onto machine A, one after one. Then one after one onto machine B. Then one after one onto machine C. Then one after one to machine D. Then one after one to machine E. So machine A competitions once it's over, then everything is blank say here. So machine B computation must be started. What time it can take next job in the sequence, first job? So machine job was busy on operations on machine A till clock time 8. It is ready for loading onto machine B only at clock time 8. Hence, at clock time 8 only, machine B starts its operation on first job. So plus operation time for the first job on the second machine, machine B, 6. 8 plus 6, 8 plus 6 equal to 14. So at clock time 14 only, machine B can take download machine, unload unload job 1 and ready for taking the next job in the sequence. 14. So third job was ready by 13, clock time 13 itself. It is ready. It has come to the machine B, but it cannot be loaded onto this way because machine was busy up to clock time 14. So this machine B can take the third job for loading only at clock time 14. So operation time for the third job on machine B is 4 minutes. So 14 plus 4, 18 minutes. Right? So at clock time 18 it is over. Job is unloaded. Next machine has to wait. Why? Because next job was in operation on machine A up to clock time 19. Though machine has completed the previous job by 18 here, job was held up in the previous machine up to clock time 19. Only at clock time 19 this job can be loaded onto this machine, not at clock time 18. సో ఇది పెద్దదా ఇది పెద్దదా చూసుకో పెద్దదే ఇక్కడ వస్తుంది. So at clock time 19 it starts the operation on second job. For the second job operation time on machine B 19 plus 6 25. So at clock time 25 machine has completed the operation, whereas the next job was busy. Next job was being processed on machine A up to clock time 27. So 27 మాత్రమే లోడ్ చేయగలం machine B మీద. So not at clock time 25, at clock time 27. Why? Because job was busy on machine A up to clock time 27. Though machine has completed the previous job by clock time 25, this job has not come to this machine. So this job will come only at clock time 27. So clock time 27 load అవుతుంది. Plus 3 minutes time will be taken. So 30. Clock time 30 it comes out. Like that, machine B computations then should be completed. Then go for machine C. So at what time machine C starts its operation on the first job only at clock time 14. ఇక్కడ 14 వరకు ముందు దాంట్లో ఉండిపోయింది ముందు మిషన్లో. సో 14 స్టార్ట్ అవుతుంది. ప్లస్ ఆపరేషన్ టైం ఆన్ దిస్ ఫస్ట్ ప్లస్ 4 ప్లస్ 2 minutes. సో 16. ఇక్కడ 16కి అయిపోయింది. నెక్స్ట్ జాబ్ 18 వరకు ముందు విషయంలో బిజీగా ఉంది. 18కి మాత్రమే ఇక్కడికి వస్తుంది. సో 18. సో 18 ప్లస్ ఆపరేషన్ టైం ఫర్ ద థర్డ్ జాబ్ ఒరిజినల్ టైం ఆన్ మిషన్ సిసి 18 ప్లస్ 5 23. 23కి అయిపోయింది. బట్ నెక్స్ట్ జాబ్ వాజ్ బిజీ ఆన్ మిషన్ బి అప్ టు క్లాక్ టైం 25కి లోడ్ చేయగలం. సో లైక్ దట్ 4 minutes ప్రాసెసింగ్ టైం అట్ క్లాక్ టైం 28 కమ్స్ అవుట్. సో 29 వరకు 29కి అయిపోయింది జాబ్. Machine has to wait for some time because the job was busy in the previous machine up to clock time 30. So at clock time 30 when it can be loaded. So plus 3 minutes time for machines for job 4 on machine C. So 33. So like that machine C computations must be done. Then machine D computations. Then machine E computations. So So total time taken for completion of all the jobs is 53 minutes. So in the span of 0 to 53 minutes, from 0 to 8, 8 to 13, 13 to 8, 19, 19 to 27, machine A was working only from 0 to 27, clock time 0 to clock time 27. Thereafterwards, machine A was idle. So how much time machine A was idle? In the span of 0 to 53 minutes, 53 minus 27. That is the idle time for machine. So total option time is 53. Idle time on machine equal to 53. Total time taken is 53. And this machine A has completed the works on all the jobs by clock time 27. Thereafter, machine A was idle. Hence 53 minus 27 is the idle time. Hours lo అనుకున్నాడు hours లో అనుకుంటే hours అని రాయండి. Then idle time on machine B అంటే machine B started its operation at clock time 8. అంటే first 8 hours it was idle. First 8 hours it was idle. Then 8 to 14, 14 to 18, ఇక్కడ మళ్ళీ 1 hour waiting. సో ఇక్కడ ఫస్ట్ 8 hours, ఇక్కడ మళ్ళీ 1 hour, ఇక్కడ మళ్ళీ 2 hours, మళ్ళీ 30కి అయిపోయింది. సో ఫస్ట్ 8 hours, 1 hour plus 2 hours. After 30 hours, after clock time 30, the machine B was not functioning, was idle. So 53 minus 30, అది 30 నుంచి 53 వరకు అక్కడ ఐడిల్గా ఉంది. సో 53 minus 30. సో అవన్నీ కూడుకుంటే you'll be getting 34 hours idle time on machine. Similarly, idle time on machine C. The first 14 hours it was idle, 14 hours. అక్కడ 14 hours ఐడిల్గా ఉంది. తర్వాత 16 to 18 చూడండి, 16కి ఇక్కడ ఆపరేషన్ అయిపోయింది. నెక్స్ట్ జాబ్ వాజ్ టేకన్ ఆన్ 18 hours. సో ఇక్కడ 2 hours ఐడిల్, ఇక్కడ 2 hours ఐడిల్, 23, 25, ఇక్కడ 1 hour ఐడిల్, ఇక్కడ 14 hours, ఇక్కడ 2 hours, 16 to 18, 18 minus 16, 25 minus 23, 30 minus 29, ఇవన్నీ ఐడిల్ టైమ్స్ ఇక్కడ. అండ్ at clock time 33 it has completed all the operations. So from 33 to 53, another 20 hours it was idle. So total idle times on machines is 14 plus 2 plus 2 plus 1 plus 53 minus 20 hours. So altogether 30 hours. So like that, idle times must be computed on machine D and machine E also. That's all. It's about this one. So this 50 machine data will have to be used only for determining the sequence, only for determining the best sequence. Once the sequence is determined, this data will not be applied anywhere. This data need not be used anywhere, remember. So once again, for computation of the time in, time out on all the machines, total time computations and all, you have to use original data, original machine data. Original machines A, B, C, D, E are the original machines. G and H only are fictitious machines. They have assumed only to find out the best sequence of the jobs. That's all. And we are calculating the total offset time, idle times on machines, etc. Original machines data only, original time data only on original machines, real machines must be taken into account, and they must be employed in the computations, the last table.